So we'll be going through version control, and let us begin. So what is version control? Basically, it's just software that helps, it's a set of tools that helps you manage changes in your software over time. So you can think of it like a video game. I'm sure many of you have played video games before, and you have a checkpoint system where you save progress as you go along. And if you mess up or you die in a video game, you can always go back to a previous version. So that's how it is. And the same way as a video game, you can branch out and make choices and then come back to those choices if you feel like you've messed up. So that's essentially what version control is. So now what's Git? That's the version control software that we'll be using today. So it's the most widely used version control software in the world at the moment. There are others, but we'll not be covering them today. So it was created by Linus Torvalds. You might know him as the creator of Linux. Pretty smart guy, if you asked me. So Git is known as a distributed version control system. This is opposed to a central version control system. So in a central version control system, the repository, so where all the data is stored, a repository is basically where data is stored, like a central place. So the repository is typically in one central position. And if you want to make changes, you actually have to commit changes to that central place. But Git is different. Git is a distributed version control system where every single person has a local repository on their machine. So you can make changes to that local repository and people can access that local repository. And this is better because it allows you, it's generally a safer idea, not putting your eggs in one basket. So in a sense, everyone gets a slice of the cake. That's essentially what Git is. So what is GitHub? So I've noticed people often confuse the two terms, Git and GitHub. They're not the same thing. So GitHub is a platform to host your code and you manage this code using Git. So think of this as Git is to GitHub what videos are to YouTube, right? You can't have YouTube without videos, right? So that's how it is. So it's the most popular hosting platform in the world currently. But you should know that there are other platforms that exist. You have GitLab and you have Bitbucket. From what I've been told by people in the industry, GitLab is, in terms of features, far more advanced than Bitbucket and GitHub, but they offer these special features for enterprise software, as in people who work in the big business, and you most likely won't come across those features in your daily life. As a student, don't worry about it, just stick to what we're handling today. So why does this all matter? Why are we here today? It matters because it allows you, it keeps track of you, the progress you've made. So you have all these separate checkpoints and it allows you to go back if you've messed up in your code. I'm sure many of you have tried out a new feature or tried out a huge chunk of code and then you find out, oh man, this is broken, everything. I'm gonna spend all night trying to fix this. But with Git and with GitHub, it allows you to simply revert to a prior point in your software where it was working. So you're safe. It allows you to try out new features. So with the branching feature, there's a feature called branching, right? You have the master branch, which is the main branch where you will be working on things, and then you can branch out. You can create maybe your own personal branch, like maybe version 1.2. I'm trying out maybe this new module or this new library, but I don't know if it'll mess up my main software. So I don't really want to try that. So I'll create a separate branch to try it out. If it works, then good, we merge it back into the main branch. So it allows you to try new features without fears of breaking anything. And GitHub in particular allows you to create a portfolio of your work. I don't know if you guys have made any CVs yet, but it is good practice to have your GitHub link on your CV. Interviewers will expect it. And finally, it allows you to work as a team. So I don't know if you've tried coding without a version control software, and it can be quite difficult to share code between people because everyone's trying to type on the same piece of code, and it just ends up messy. It's just it's unworkable basically. You can make it work, but it's generally a really big pain in the ass. So Git and GitHub allow you to work as a team in tandem at the same time, working on multiple features without messing up the main code. Everyone has their own separate repository on their own machines. They're creating modules, they're coding, they're doing everything, and then when it matters, they mix it into the main branch. And Git allows you to do this simply. Like it even keeps track of changes and it'll notify you, okay, this code has been inserted here. Do you want to replace it or do you want to use your own code for it? It's really intuitive. So today we'll be using the command line interface for Git. I hope everyone has gone ahead and created a GitHub account and installed Git on their machine. So I'm going to work with those assumptions. So to begin, I want you to go to your desktop and create a new folder. We can call this whatever you want to call this, maybe workshop or Git or whatever you want it to be. So what we're going to do is we're going to open Git Bash here. So now Git Bash, essentially what it is, this is particular to Windows. On Linux and Mac, you can just open up the terminal. It doesn't matter. Git Bash is an emulation of a Unix terminal. That means it's going to pretend to be the terminal that you see in Linux or Mac. So all the code that works on a Linux terminal will work here. So to initialize a Git repository, we write git init. And you can see this hidden folder that's been created here. That's your Git folder. So now it'll, sorry. I see somebody has written something. Oh, okay, Emery has just sent the link to the chat to do that. So Git, this hidden folder basically just keeps track of your changes. So it saves your save state, right? So we'll go ahead and create a HTML file, the most basic of coding, taste.html. See? So now this feature isn't in Windows. I'm sure you know that. This feature isn't in Windows. It's in Unix system, so it's in Linux and Mac. So you can do touch test.html. And that you can see here, we've created an HTML file. Yeah. So now I'm going to open it up with my favorite text editor, coding text editor. You can use Notepad++, you can use Atom. I personally like VS Code, and the code to open VS Code is code test.html. So you can see here, as VS Code takes its sweet time to open, you can see we've opened it up. So that's called a snippet. I can send you these information if you want. We're going to make some changes. So we've created a basic HTML boilerplate, and we're just going to say this is the Git workshop as the title, and we save that. Now we've saved it, but in essence, Git doesn't know that what we've put in when what we're trying to save, it doesn't know what the save state is. So now think of this when I say git add test.html. Think of this as going to a supermarket where you're shopping for items. So when you say git test add HTML, you're picking off HTML from the shelf and you're putting there. And then see, I've added it to the staging area. When you add something, you're adding it to the staging area. Think of the staging area as your shopping basket. And then you do git commit -m. M stands for message, and this is to let your team know what you have actually done. So here we'll say created a HTML file, right? You have to put a message to explain what you've done. It's good practice, and you'll be expected to do that when you work as a team. So essentially, we've created a safe state. We've created a checkpoint. Now we can always come back to this. Even years down the line, we can always say, okay, I want to go back all the way to the start, and we can just revert everything back to this point. It's a safe state, and your work is basically safe now. Alternatively to Git add, I'm sure if you've worked with the Android Studio or any complex project, you'll have more than one file. So you can do git add full stop. That adds everything to the staging area, and then you can press up a few times and you can just say showed how to add all. So yeah, it's basically telling you I'm on the branch master, there's nothing to commit because we've already done this before. There's no use of doing it again. So this is fine and dandy, but we want to push our code to a centralized place, and that means creating a repository on GitHub. So go ahead and log into your GitHub. You can see these are, as you work as a team, you can see the progress that people have made and the contributions they've made to the project. I haven't worked on this in a while, so yeah, my GitHub is impressive. You can, okay, this is my main GitHub page. This is what happens, this is what it looks like when you log in. You create a new repository, and you can call this repository whatever you want. Let's just call it workshop. And these are settings that you can add to it. You can add a README file. In general, if you're trying to make your project public and you want people to know what your project is about, you add a README file. This is something else. We won't touch it. Pardon? So anyway, these details, these get ignore. You can do your own research with that. I'm not going to touch it today because we have such a limited amount of time. Go ahead and create that repository. Pardon me. So once you have done that, we want to now link the repository on our computer to our repository online. We have another question. Okay. So Emery has posted a link, a Udacity link. If you want to do something more advanced, you can follow that link. So we copy this, and then we type the code back in our repository. We now want to link our local repository to the online repository. And how do we do this? We write git remote add origin, and then we go ahead and paste this here, the link. So if you're setting this up for the first time, it's going to prompt you for your Git email and your Git password. Go ahead and fill those out, and then we git push. Push means you're now taking what you have locally and you're pushing it online to that repository you created, master. Wait, origin. Okay, so yeah, we have done that. So now when we come here and we look at the code, we'll be able to see our test.html. We've created an HTML file. It wasn't here before, now it is. So let's assume that we've been working on this, right? And maybe after a night of heavy drinking, we just come around and mess with our code and write all that trash, right? It's basically garbage. We've saved it in our drunken state. We git add all. We committed it, git commit dash m. I'm drunk right now. I don't know what I'm doing. We messed up. We basically messed up our code. So we even went ahead and git Okay. We go ahead and do that. In our drunken state, we've really messed up our code. And you see, these are the nonsense we put inside. So we're messed up, and we want to go back to the previous state. We want to see, we want to go back to what you've done. Here we can see a history of commits. So now this is your checkpoints. This is what you've done in the past, and this is all the progress that you've made. So we don't like this. We want to go back. So what we do is we copy this value, right? We copy that value and we say git revert, and then we paste it. So we could have done -m. We could have done -m to put a message automatically, but if you don't put the -m, it's going to open up your chosen code text editor, and it's going to ask you to leave a message. Yeah, you can just write 1 or yeah. Okay, you save it and it'll commit. Now it's made a commit, right? So now we git push q origin master. Now we're making changes back to the thing to tell it, yeah, we've reverted the change and we messed up and we want to go back to doing it. So here you can see revert, I'm drunk. So now every change that we've made in I'm drunk is now it's back to normal. So it's like it never happened, right? That's a great thing. So if you mess up your code, you can always revert the previous commit and go back to a previous state. You're safe from it. So the next step I want to do is I want to show you how to add collaborators and then to work as a team. And then that I'll show you how to add collaborators, and then I'll pass this session on to Emery, and Emery will take you through branching, and he'll take you through adding a remote repository to your current, creating a remote repository. So yeah, so we can copy that. And we come here, settings. So now you have to get somebody's email address, right? You come to manage access. Please somebody tell me if I'm going too fast. That is not my intention. I'm trying to be as clear as possible. So you invite a collaborator, and Emery has sent me his GitHub email address, and I'm going to add him as a collaborator. So Emery Bashige will get the request in his email address, he'll follow it up, and he'll accept being added as a collaborator. So when you're working in teams, collect all your teammates' email addresses and add them as collaborators so they can work with you on the same repository at the same time. They can switch computers and still have the access that at any time they can access the remote repository and work on it. So let me pass this on to Emery right now. Emery, go ahead and take the wheel.
Yeah, thanks, Abdul. So just a second, I share my screen. Yeah, okay. So right now I'm looking at Abdul repositories that he has just created. And what we're going to do is I'm going to fork that repository, make changes to it, and then make a pull request. So first of all, why fork a repository? So when you fork a repository, what it does is it creates a copy of it on your account. The difference with cloning a repository is that it's you just download it on your computer, but you don't have access to it from your GitHub account. So I'm going to fork it. Okay. And then I'm going to pull the repository in my local computer. As Abdul showed you, always start with git init and then git pull, which will sort of download the repo on my local system. Okay, so now we have it. We can make changes to this repo. Sorry for that. Jeez. Sorry. Okay. So let's say I want to add a line here that says so yeah, I've added a line there. I've made some modification on that repository, and I can push those changes to my account directly. But maybe I want Abdul opinion on it, on whether we should keep it or not. And for that, we should use branches. We should create another branch and commit those changes to that branch, because maybe Abdul doesn't want that change on his remote repository, and we need to review the change that we have made. So for that, we should use branches. So far we've been just committing all our changes on the master branch, and our head must be pointing somewhere here on the branch that we are currently on. But once we create another branch, let's call it development, and commit changes to that branch, we can avoid having issues on our production code if, let's say, the code that we have committed is faulty. So there is two different ways to create a branch. We can just do git branch and then give a name. Or what I'm going to do is I'm going to do git checkout, which is going to switch to the branch that I'm going to create, and then do /b and then the name of the branch. It's dev. So now I'm on the dev branch, and I'm going to add the changes that I made and commit them. I'm just going to give a random name there. Okay, now that I have like a different branch committed to my repo, added to my repo, what I can do is I can push the code to that branch on my remote repository. First of all, I need to check if it is added there. If what I'm doing there is that I'm checking if my remote repository is added on my local file, which it's not, so I'm going to add it. So if we run this code again, now that remote repository will be added there, and then I can push the changes that I've made to that remote repository. Git push origin dev. So because this branch is called dev, so now that I've pushed those changes, what I can do is I can ask Abdul to review the code that I've committed, and then if he approves of it, he can merge them into the master branch on his repo. So for that, we go to compare and pull requests. And then you leave a comment. So yeah, now Abdul can confirm, he can admit like those changes or ask me to make any change to make sure that my repo comply with whatever standards that he might have on it. And note that I did this because Abdul didn't give me right access to the repo, but if he did, I only needed to do a pull request. I could have committed the changes directly to his repo. So yeah, that is it. I don't know if like Abdul can do a demo on accepting pull requests, and then we can answer.
I'll go ahead and do that. So here we're back in the repository that we've made, and we can come to here and see pull requests. So now it might be tricky to differentiate between a pull request and a push, but essentially what a pull request is just asking approval from maybe your team lead to check out the code that you've made and just make sure that it's actually working. Oftentimes when we're working on our own code, we tend to miss some errors that might severely break something in the master branch. So when you're working as a team, it's good practice. It's very good practice to create pull requests. So just somebody can review the code and say, yeah, this is okay. You can go ahead with it. And something else I like to note is repository hygiene or Git hygiene. Is in general, you should try to avoid working directly on the master branch. I've personally experienced this, and I know several groups of people within USIU and outside in the working field that have been pushing changes directly to the master branch. And the master branch is the big daddy, the main repository. So if you mess it up, it could severely break things. So in general, I would advise you to, unless you're working on your own personal project, just create our own branch when coding. You can always merge it back to the master, it won't matter, but in general, keep your master branch clean and only merge things there when you're certain that everything is okay. So let's go ahead and see addition, right? So I can see here, this branch has no conflict. This branch has no conflicts with the base branch. So that means that there is nothing that is added. We can see files is changed. We can see the difference in itself. You see now you see the power of Git and GitHub. It's actually showing me exactly the changes he's made, exactly what he's done. And then I can see, okay, yeah, this is fine. It's just, we should use Bitbucket. Yeah, it's a good idea. And I can see the commits he's made and the messages he's done. I can even see the hash for the commit code. We can remember, we can use that to revert. And I see, okay, yeah, Emery has done good work there. I don't see any issues with it. So I can leave a comment. I can say, yeah, good work, Emery. Emery, everything seems fine. And then I merge the pull request. And then I can see his commit message there and confirm merge. So now his branch that he created is now merged with the master branch. So everything he's done is now on the main branch. Do you get that? So we can see now, we can see in the master branch, we can see his changes, but we can also see, well, he hasn't pushed his own main branch, but that's okay. You can also see any other branches created there if they have been pushed to the GitHub repository. So one more thing I want to talk about, oftentimes you'll have, we're using we're using the command line interface tools for Git. However, some graphical user interfaces exist for version control. You don't necessarily have to do this, but it's an essential skill to know. If you prefer working with a GUI, you can just you can see GUI clients. You can see a bunch of them here. Some of them are free, some of them aren't. I personally have GitHub desktop here. I believe I do. Might have deleted it. See, I have GitHub desktop here. So essentially, if you don't like, you're not a hacker type, you don't like using the command line, you can see all your changes now using a graphical user interfaces. You can do everything we've done. For the most part, there's some features that you can't do on the GUIs that you can do on the command line interfaces. But as I said, if you're not comfortable doing this, you can use a GUI client for this, and that'll be great. I think that's it. I think we're done for today. Unless anyone has a question, anyone wants something clarified, go ahead and raise your hand and I'll attempt to answer them. Any questions? Okay, can I ask then, have you learned something new or did you already have all this information? Any volunteers?
Perhaps I can go.
Okay, go ahead.
I think I've learned something new on top of what I had on GitHub. So that this session was actually really useful.
All right, that's great to know. So I'm going to drop a feedback form. I would love it if you actually filled out the feedback, and it'll also give us information on what direction that we want to take next. Sandra, the video for what?
See, you guys are recording the session.
Yes,
I can
it'll
see
be
the
posted
session is
on.
being recorded.
Yeah, it'll be posted on YouTube, and I'll share the link with everyone. So I'm dropping a Google Forms there. Please take the time to fill it out. It'll give us an idea on where to take this Google Developer Students Club next. We have plenty of ideas. We're thinking of starting different ICT tracks, maybe cybersecurity, mobile programming, web development, and next time we'll actually, from week 1 to week 14, we'll be building a project, maybe a web app, maybe a mobile app, maybe we'll hack something or do some hack the box challenges on the cybersecurity track. So go ahead and fill that form. Let us know what you think. And thank you very much for your time. I hope you have learned something new. If you have any questions, I'm going to drop my number and I'm going to drop my email address. You can just ask me at your own convenience. Thank you very much. I guess we can go to our next class now. If you have a next class, if not, then enjoy the rest of your weekend.